Hello everyone, I welcome you all to my channel Wins Academy for Competitive Exams. In this video, we are going to see Norton Theorem, which is used for solving problems in electric circuits. To recall the basics of electric circuits, you can refer the links given in the description box. Our learning objectives are Norton Theorem, equivalent circuit, steps to solve the problems, and some problems that are asked in the competitive exams. So first, let us see what is the statement for Norton Theorem. Norton Theorem states that any circuit with voltage sources, resistances can be reduced to a current source parallel with Thevenin's resistance, where the value of the current source is equal to the current, that is Norton current IN, or the short circuit current ISC, passing through the short circuit output terminals. So in simple, if you want to say, means Norton theorem means it consists of a current source parallel with the Thevenin's resistance. Now let us see the equivalent circuit for Norton's theorem. So for any complex active network, RL is the load resistance connected. It can be converted into a current source parallel with Thevenin's resistance and which is connected across the load resistance RL. So IL is the current flowing through the load resistance. Here IN is the Norton current or short circuit current. The load current can be calculated using the formula IL is equal to IN into RTH divided by RTH plus RL. So this is nothing but the total current into other branch resistance divided by sum of the branch resistances, that is IL is equal to IN RTH divided by RTH plus RL. Next we are going to see steps to solve the problem. So first step, remove the load resistor RL. Then open circuit the current source and short circuit the voltage source. After that find the equivalent resistance, that is R Thevenin. Then find the short circuit current IN. Then at last, if RL is given, then using the current division rule, we can find IL. IL is equal to IN into RTH divided by RTH plus RL. So first problem. Applying Norton's theorem, the Norton's equivalent circuit to the left of the terminals A and B in the below circuit is having equivalent current source IN and equivalent resistance Rn as. That means we have to find what is IN and Rn. Rn is nothing but Thevenin's resistance. Then IN is the Norton's current. So we have, this is a circuit given. Here this is an voltage source and this is a current source. So first we have to find the Thevenin resistance, that is Rn. So open circuit the current source and short circuit the voltage source. So you will get the circuit like this. Now we have to calculate the equivalent resistance. Since 4 ohm and 4 ohm are in series, we can add it. Then that result is in parallel with the 8 ohm. So Rn is equal to 8 divided by 2. Because both the resistance values are same, means for parallel we can write R by 2. So 8 by 2, that is equal to 4 ohm. Now we have to calculate the Norton's current. So next we are going to find the Norton's current. So for that we have to short circuit it. So that only we are saying this Norton's current as short circuit current. So this 2 points gets short circuited. Then we have to convert this voltage source into a current source. Then it will be easier for us to use the nodal analysis. So by using Ohm's law, we can convert the voltage source into current source. So the current value is equal to 6 amperes. Since 24 divided by 4 is equal to 6 V by R. So 6 ampere is the current value. Then this resistor is connected in parallel to the current source. Since this is short circuit, there will be no current flowing through this 8 ohm resistor. So we can remove this 8 ohm resistor. So you will be getting the circuit like this. Now we have to apply the nodal analysis. Here only one node is there. This is V. So according to, if you are using nodal analysis means then we have to use Kirchhoff's current law. So according to Kirchhoff's current law, the sum of incoming current is equal to sum of outgoing current. So at this point, that is at this node, the incoming currents are from here, then from here. So through this resistor and through this resistor, it is outgoing current. So we can write 6 plus 4 is equal to, the current flowing through this resistor is V by 4. That is by using Ohm's law, V by R, V by 4. Plus through this resistor is V by 4. So from this we can find the voltage V is equal to 20. Next we can find the IN current. So IN current means the current flowing through this resistor 4 ohm. So already we have calculated what is V. So IN is equal to V by R, that is equal to 20 by 4, that is equal to 5 ampere. So option A is the right answer. So next problem. Norton equivalent to the network N to the left of AB is a current source IN equal to 4 ampere from B to A. RN equal to 2 ohm. The current through R when it is connected across AB is equal to 2 ampere. What is the value of the resistance R? So here the Norton current, Norton resistance, everything is given. So we have to calculate what is the value of this resistance R. So first we have to draw the equivalent circuit of the Norton theorem. So here there is a current source parallel with the Thevenin resistance or Norton's resistance. Then it is connected across the load resistance RL. RL here is R. Then by using current division rule, we can calculate what is the load current. That is IL is equal to IN into RTH divided by RTH plus RL. That is IN is the total current, RTH is the other branch resistance divided by sum of the branch resistances. So IL is given equal to 2, that is equal to 2 into 2 divided by 2 plus R. So from this we can calculate the value for R. R is equal to 2 ohm. So option B is the right answer. Next problem. The Norton equivalent between A and B for the circuit is. So we have to find the Norton's equivalent circuit. That means we have to calculate the Norton current and the Thevenin's resistance. So here in the circuit given 2 volts is the power supply given, 3 ohm, 0.8 ohm and 2 ohm are the resistor values. So first step is to find the Thevenin's resistance, that is equivalent resistance. So we have to short circuit this voltage source. If we short circuit this voltage source, we will be getting the circuit like this. Now we have to calculate the equivalent resistance or Thevenin's resistance. So these two resistors are in parallel and it is in series with the 0.8 ohm. So you will be getting RTH is equal to 3 into 2 divided by 3 plus 2 plus 0.8. So that is equal to 2 ohm. Then we have to find the short circuit current or Norton current. So for that we have to short circuit these 2 points A and B. So you will be getting the circuit like this, and the current flowing through this 0.8 ohm resistor is IN, that is the Norton current. So here we are going to apply nodal analysis at the node V. So since we are applying nodal analysis, we have to convert this voltage source into a current source. So if you are converting voltage source into a current source, you will be getting a current source parallel with the resistor. So by using the Ohm's law, we can get the current value as 2 by 3 amperes. That is, this is V, this is R. So V by R equal to I according to Ohm's law. Then after that, we have to apply the nodal analysis. So nodal analysis means here we are going to apply the Kirchhoff's current law. According to Kirchhoff's current law, the sum of the incoming current is equal to sum of the outgoing current. So this is the point node, means the incoming current is this 2 by 3 ampere. This is incoming current, and the outgoing current is the current flowing through 3 ohm resistor, the current flowing through 2 ohm resistor and the current flowing through 0.8 ohm resistor. So we can write V by 2 plus V by 0.8 plus V by 3. So from this, on simplifying it, we will be getting V is equal to 0.32. Then we can calculate IN. IN is equal to V by R. R means this resistor, 0.8. So that is equal to 0.4 ampere. So option D is the right answer. So next problem. This is an AC circuit problem. In the circuit shown below, The Norton equivalent current in amperes with respect to the terminals P and Q is. So this is the circuit given. We have to find the Norton's current. So for that, just short circuit both the points. If you are short circuiting it, no current will be flowing through this capacitor. So this capacitor value is nullified. Then by using current division rule, we can write IN is equal to Norton's current is equal to total current. What is the total current? 16. Total current into other branch resistance, that is 25. 16 into 25 divided by sum of the resistance values. Resistance or impedance value. So 25 plus 15 plus J30. Then we have to simplify it. This is in complex form. So that is equal to 6.4 minus J4.8. So option A is the right answer. Now, I hope you all understood what is Norton's theorem and how to solve the problems using Norton's theorem. If you like this video, kindly subscribe it and share it to your friends. Let us understand and grow. Thank you.